Imagine a tractor working an entire field with no farmer sitting behind the wheel. No steering. No long hours in the cab. No stopping every few minutes to correct the tractor's path. Sounds like science fiction? It's not. Self-driving tractors are already changing the way American farmers work, and what happens next could completely transform modern agriculture. But here's the surprising part: the biggest change isn't that tractors can drive themselves, it's what farmers can do with all the time, fuel, and precision they gain. For generations, farming has depended on one thing above all else: human labor. A farmer climbs into a tractor, starts the engine, drives across massive fields, plants crops, applies fertilizer, and eventually harvests them. And depending on the size of the farm, that can mean hundreds, or even thousands, of hours behind the wheel every year. But American agriculture is facing a major challenge. Farms are getting larger. Labor is becoming harder to find. Fuel and equipment costs continue to put pressure on farmers. And farmers are being asked to produce more food with fewer resources. That's where autonomous tractors enter the picture. These machines combine GPS guidance, cameras, sensors, artificial intelligence, and advanced software to perform farming tasks with little or even no direct human control. And this isn't simply about making tractors drive themselves. It's about turning the tractor into a smart agricultural machine. So, how does a tractor actually know where to go? Modern autonomous systems can use highly accurate GPS technology to create digital maps of a field. The farmer can define the boundaries, establish the route, and tell the machine what job needs to be done. The tractor can then follow planned paths across the field while maintaining extremely precise positioning. But GPS is only part of the technology. Cameras and sensors can help the machine understand its surroundings. Artificial intelligence can process information from the environment and help the tractor make decisions while operating. For example, imagine a tractor planting thousands of rows of crops. Instead of relying entirely on a human driver to maintain a perfectly straight line for hours, an autonomous system can continuously adjust its position. That precision matters. Because even a small error repeated across hundreds of acres can mean wasted seed, wasted fertilizer, wasted fuel, and ultimately wasted money. But there's one important misconception. Self-driving tractors don't necessarily mean farmers are becoming unnecessary. In many cases, the farmer simply moves from being the person physically driving the machine to being the person managing the technology. Think of it this way. Instead of spending 10 hours sitting in a tractor cab, a farmer could potentially supervise multiple operations, monitor equipment, inspect crops, manage irrigation, or deal with problems that actually require human judgment. The tractor does the repetitive work. The farmer focuses on the decisions. And that could become one of the biggest advantages of autonomous farming. But there's something even more interesting happening. The next generation of autonomous tractors isn't just being designed to follow a straight line across a field. These machines are becoming part of a much bigger farming system, one where tractors, drones, sensors, artificial intelligence, and farm management software can work together. And when these technologies start communicating with each other, the farmer may no longer be simply operating a tractor. They could be managing an entire autonomous farm. And that raises a much bigger question. How much can this technology actually save an American farmer, and could autonomous tractors eventually change what a farm workforce looks like? That's where things get really interesting. Now let's take this one step further. Imagine an American farmer managing hundreds or even thousands of acres. Instead of one person spending the entire day driving a tractor, autonomous machines could operate for extended periods while the farmer monitors their progress. That changes the economics of farming. Less time spent behind the wheel can mean more time spent making decisions. And when the machine can operate with extreme precision, farmers may also reduce unnecessary passes across the field. Every unnecessary pass costs fuel. Every unnecessary pass takes time. And every unnecessary pass can contribute to soil compaction. Autonomous technology is designed to make those operations more precise and repeatable. Fuel is another major factor. A large agricultural tractor can consume significant amounts of fuel during long working days. If an autonomous system can plan efficient routes and reduce unnecessary movement, the potential savings can become substantial over an entire season. But the real value may come from combining autonomous driving with precision agriculture. Instead of treating an entire field exactly the same, farmers can use maps, sensors, and data to understand where crops need more attention and where they don't. That means equipment can become smarter about where it drives and what it does. And this is where autonomous tractors become much more than machines that simply drive. Artificial intelligence is becoming increasingly important in modern agriculture. AI can help analyze enormous amounts of information, from crop conditions and soil data to weather patterns and equipment performance. Now imagine connecting that intelligence to an autonomous tractor. The tractor isn't just following a route. It's operating inside a digital farming system. A drone might identify an area of a field showing signs of stress. A sensor network could detect changes in soil conditions. Farm management software could process that information. And autonomous equipment could then be directed toward the area that needs attention. The result is a farming operation where machines are not working independently. But there is another reason autonomous tractors are attracting so much attention in America. Labor. Farming has always required people willing to work long hours, often under difficult conditions. But finding enough skilled workers can be challenging. Autonomous equipment could help farmers handle repetitive operations without requiring a person to sit behind the steering wheel for every hour of every task. That doesn't mean farms will have zero workers. Instead, the jobs may change. Farmers and workers could spend more time maintaining technology, analyzing data, monitoring crops, repairing equipment, and making higher-level decisions. In other words, the farmer of the future may need to understand both agriculture and technology. However, autonomous tractors are not magic machines. They come with challenges. The technology can be expensive. Farmers need reliable connectivity, accurate positioning systems, software, maintenance, and technical support. And real farms are not perfectly controlled environments. Fields can be muddy. Terrain can change. Weather can become unpredictable. Equipment can encounter obstacles. That means autonomous systems need to be extremely reliable before farmers can trust them with expensive equipment and valuable crops. So the transition won't happen overnight. But the direction is clear. Agriculture is becoming more automated, more connected, and increasingly data-driven. And here's where the future gets fascinating. The tractor may eventually become just one part of a much larger autonomous farming ecosystem. Drones could monitor fields from above. Ground robots could inspect individual plants. Sensors could monitor soil conditions. AI could analyze the data. And autonomous tractors could perform physical tasks based on those instructions. Instead of one farmer manually controlling every machine, a farmer could potentially supervise an entire network of intelligent equipment. The farmer wouldn't disappear. The farmer would become the manager of the machines. And that could completely change what it means to run an American. So, are self-driving tractors going to replace farmers? Probably not. But they could replace a huge amount of repetitive work. And that may be the real revolution. Because the future of American agriculture may not be about having bigger tractors. It may be about having smarter tractors that can work together. And as autonomous technology continues to improve, the farms that adopt it early could have a major advantage in productivity, efficiency, and operating costs. The question is no longer whether tractors can drive themselves. The real question is, what happens when the entire farm can start thinking for itself? That is the next stage of the agricultural revolution.